So this is our combination video for our special triangles, our 30, 60, 90 and our 45, 45, 90. So we're just going to be doing some examples today that are a combination of those two types. So our first example here, we're going to be finding x and y. So we have an equilateral triangle here. It's 60 degrees here, so then this side would be 30. We know that our long side for our triangle is 12. And if you remember when we talked about our 30, 60, 90, we said that 12, the long side, is equal to x square root of 3. Okay, so if I'm wanting to find this down here, we'll call this x, this will be 2x. Then this is going to be x square root of 3, so we're just going to solve. So the square root of 3. So then on the right hand side, those become 1. We're left with x equals, this is 12 divided by the square root of 3. So then if you remember, we can't leave that radical down there, so we're going to take it times square root of 3 over square root of 3. So on the bottom, those radicals cross out, we're left with 3. On the top, we have 12 times the square root of 3. The bottom is 3. Our 12 and 3 have 3 in common. So then 3 goes into 12 4 times, it goes into 3 once. So we end up with 4 square root of 3 equals x. That's this piece. So then if I want this whole length, I'm going to take that times 2. So 2 times my 4 square root of 3 equals 8 square root of 3. So this value is 8 square root of 3. Then for y, we know for y we're going to take this short side times 2 to get that as well. So y is actually the exact same thing. So x and y equal 8 square root of 3 there, because this is equilateral, all the sides are the same length. Okay? Let's go on to our next example here. So for this example, we're actually going to have a combination of different triangles going on here. We have 3. There's a small triangle, there's a medium triangle, and then there's the big triangle. So we're going to be working with all of that in order to find our pieces. So for this one, we have 60 degrees, we have A, we have x is over here, b, y, and then this entire side is c. So for the first part, we're going to be looking at a. So if we know that a is 10 square root of 3, then we're going to be finding CE, which is this piece here. So that's our long leg. And we're also going to be finding y. So y is actually over here on this other triangle. So it's the long leg of this triangle. So the first thing we're going to do then is we're going to work on finding CE. So I'm actually going to redraw my triangle so that I can see what's happening there. So I have A, which is my hypotenuse, and they said that was 10 square root of 3. And then I need to find this side right over here. That's my long leg. So in order to do that, we know that the relationship between the hypotenuse and the short leg, this is x square root of 3. So if 10 square root of 3 equals sorry about that. That one is 2x. Sorry, I was looking at the wrong side here. I was looking at this one. So this one is 2x if this is x. So then my x would be 5 square root of 3. And then I still need to find this longer one. That is our square root of 3. So I'm going to take this value, 5 square root of 3, that's my short leg, times the square root of 3 is going to give me CE. Excuse me. Whenever I multiply square root of 3 times square root of 3, we know that those square roots cross out and I'm left with 3. 5 times 3 is 15, so 15 equals CE. Okay, so that's this piece right here. So now I have this other triangle, so I'm going to go ahead and draw that. So I'm trying to find y, and I know that this CE, which is my short side of that one, is 15. So we said the relationship between the short side and the long leg is square root of 3. So y equals the short leg, which is 15, times the square root of 3, and that would be my final answer. Okay, so then we're going to continue with this same picture. So now we're going to say that x, so this piece here, is 7 square root of 3. We're going to find a, ce, y, and b. So I'm going to break these apart again. Okay, so this is my first one, so we're going to have b, e, and c. So they told us x is 7 square root of 3, and we need to find a, and we need to find CE, which is this side over here. So we know our relationships again. From here to here is times 2. Our short side is going to be times 2 to get our hypotenuse. So 7 square root of 3 times 2 equals 14 square root of 3, which is A. It's this side over here. Then for CE, we have to take our short side times the square root of 3, so 7 square root of 3 times the square root of 3 equals CE. And remember, just like we had up above, whenever we take square root of 3 times square root of 3, we're left with 3. 7 times 3 equals 21, which is CE. So then the next one, we're going on to y and b. Y and b are on this other triangle, so I'm going to go ahead and draw that out. So E is my right angle, C, A. So then we have CE, we already said was 21. So then we just need to find the other two sides. So we have Y is our long leg, and B is our hypotenuse. So the short side to our hypotenuse, we said we're doubling that. So 21 times 2 equals B. So that would be 42 equals B. And then the short side to our long side, we're taking it times the square root of 3. So Y equals the short leg, 21, times the square root of 3. Okay? So that would be all of those. Let's look at another example. So now we have this compound shape that we're going to be working with. So we're going to be finding x, we're going to find y, z, and then we're going to find the perimeter of the whole thing. Okay? So we're going to start out with our 30, 60, 90 triangle there on the left. So I'm going to pull that down here so I can just look at that piece. So this is my 30, x, and y. So from here, the first thing I'm going to be doing is finding my short leg, because the hypotenuse to the short leg we know is half. So x equals 1/2 of 8, which is 4. So this piece is 4. And then we know from the short side to the long leg, we're going to be taking our y equals the short leg times the square root of 3. So this is 4 square root 3. Okay? Then we have this other triangle over here. So we're going to come over to this side. Since these are parallel, we know that this is the same, so I'm going to go ahead and draw this triangle out here. So we said this was 4, so we know this side is also 4. If this is a 45, 45, 90 triangle, Then we know that the two legs, are equal. So if those two legs, sorry about that, so this isosceles triangle, we have 4 here, so we know this side is also 4. So then we're trying to find the hypotenuse over here, and if you remember from the other day, we said the hypotenuse is the leg times the square root of 3. So this is square root of 2. Getting my days mixed up here. Been talking about square root of 3. So this is the leg times the square root of 2 for a 45, 45, 90. Now this isn't one of our pieces that we have to know for here, but if we're going to do perimeter, we have to add all of them up. Okay, so that's why that one is important. Alright, so then from here, we also need to know z up here. Well, if these are parallel to each other, then we know if this is 6, this also has to be 6. So z equals 6. Okay. So I believe that is all of our sides. I'm going to go ahead and come up here to the top and just label these. We said x was 4, y was 4 square root of 3, z was 6. This side over here is 4. This is 4 square root of 2. Because now we're going to do perimeter, so that means we're going to add up all of these sides. So to find our perimeter, I'm going to start here with A and just go all the way around. So we have 4 square root of 3 plus 6 plus 4 plus 4 square root of 2 plus 6 plus 8, and now I'm back over here to A. So these are all of my numbers. I'm going to start combining. 6 and 4 is 10. 6 and 8 is 14. So I have 24 plus my 4 square root of 3 plus my 4 square root of 2. If I plug that into the calculator, I get approximately 36.59. 36.59, and that would be my final answer for that. Okay, let's do one more of these compound shapes. So this one, if you remember, I said that we would talk a little bit about some coordinates, so this one has our coordinates on it. So here it says, if we know that PQ is parallel to SR, then we're going to use the figure to find A, B, C, and D. So I'm just going to write those out. A, B, C, D. Those are the pieces that we are trying to find. Okay? So we see A and B, C's down here, and D is right over here. So those are the pieces that we're working on. So let's start with A, B, and C. We're looking at this 30, 60, 90 triangle. So I'm going to bring it down here. This is my 60. Here's my 30. We know that the hypotenuse is 6 square root of 3. We know that the relationship between our hypotenuse and our short side would be half. So 6 square root of 3 divided by 2, we end up with 3 square root of 3 for that side down there. And then for this one, we're taking our short side times the square root of 3. So 3 square root of 3 times the square root of 3, if you remember from our theorem. And then we said when we take a square root of 3 times the square root of 3, those square roots cross each other out. We're left with 3. 3 times 3 equals 9. So that means this long leg is 9. Alright, so I'm going to use this information to help me find A, B, and C here. So first, I'm starting at the origin. I'm going to go over 3 square root of 3 units to get over here. So that means my x value went from 0 to 3 square root of 3. Okay, now we're going to be coming straight up. This is a 90-degree angle here. So we know our x value up here at P should be the exact same as it was here at T. So A should be the same as C. So 3 square root of 3. And then how far did we go up? We started here at 0. We went up. Well, it says we went up 9 units. So B is my y value. So that should be 9. Okay. Now we're going to be moving over. This tells us that we came over to 8 square root of 3. So what is my y value? How high up here on my y is q? Well, they're straight across from each other, so that means it should be the same as b. So it should also be 9. Okay. We could go on to some of these others. E and f, we know if we come straight down that our x value should stay the same, so e would be our 8 square root of 3, and then we could do f if we want to find our 45, 45, 90 triangle here. We would be able to find f. They didn't ask for that one, so I'm going to go ahead and stop there for today. If you want to know f, I'd be more than happy to work through that in class tomorrow. Have a great day, and I will see you in class.